Hi, this is Sean Moore, and I'm going to present my Splay Tree Visualizer project. Um, Everything is hosted on GitHub, and there's also a demo hosted via GitHub Pages. I'm going to go ahead and start with explaining what a splay tree actually is. So a splay tree moves the most frequently accessed nodes to the root of the tree, and this makes it more efficient to access nodes again. So a good example is with Facebook friends. If you have hundreds of Facebook friend nodes in your friend tree, um, you may only access a dozen of those friends on a regular basis. And those regularly accessed friend nodes over time will move closer to the root of the tree. And in this way, if you want to access them again, it makes the search process much more efficient than other binary search trees. So I should also say a splay tree is a self-adjusting binary search tree. So it was invented in 1985 by Sleater and Tarjan, and it performs the splay operation, which is where it moves the selected node to the root of the tree. It performs the splay operation for insert, delete, and um, search. So it does this in a few scenarios, like if the node that's selected is already at the root of the tree, then it'll exit the splay. Um, if uh, if it, all the other scenarios are based on the parent and the grandparent. So if the grandparent and the parent are both left children or both right children, then this is called a zig-zig splay. Um, and that happens where um, the selected node moves around the parent, and then there's another tree rotation that happens, and it moves around the grandparent. Um, if the grandparent is on is a left child and the parent is a right child, um, then this is called a zigzag, or the opposite. If the grandparent is a right child and the parent is a left child, if they're the opposite child types, then it's going to be a zigzag. Um, so all of these rotations happen within the splay operation. So um, we can go ahead and the remove operation works by getting the selected node to the root of the tree, and then splitting the tree into two subtrees, and then reconnecting um, those two subtrees, which at that point removes the selected node. Um, if at any point there's a search operation or a removal operation uh, where the key indicated by the by the program doesn't actually exist in the tree, uh, then the closest node to that key will be moved to the root, and however it'll still return null. Uh, for instance, if you search for 5, but there is no 5 in the tree, um, it will return 4 if it exists. Um, so here are all the references, and now we can get into the actual demo. So um, the visualizer was inspired by a website called visualalgo.net, and so um, This site has all sorts of presentations and demonstrations on algorithms and data structures, but they do not have one on splay trees. So using JavaScript, CSS, um, and HTML, I put together a demonstration of how to visualize splay trees. The splay tree implementation is purely in JavaScript. It's modeled after a Java implementation by Robert Sedgwick and Josh Israel. Um, for the presentation, or for the GUI, I used Bootstrap, the CSS framework, and for the splay tree connectivity, I use D3.js. Um, so uh, the system requirements, please use Chrome or Firefox. And if you're going to use Internet Explorer, just make sure it's version 10 or higher. There's some more modern uses of JavaScript, so they may not display properly on older browsers. Also use a large screen size. If using your phone, it will require a lot of scrolling, um, whereas on a desktop or a laptop or even most tablets, it'll display properly. Um, so these are just instructions on how to use it. We're going to be adding or updating the tree, removing items from the tree. You can find items, you can find the min or min or the max. And there are some operations that the splay tree has implemented. However, they are not part of the visualization. So I'll go ahead and show what the code looks like real quick. So here's the Splay.js file. And this is a node object constructor in JavaScript. So every node is going to have a key. Every node is also going to have a value. This is the left child, and this is the right child. This is the basic Splay binary search tree constructor. It just has a null root that it starts out with. This is the search operation. It starts with a splay, and then if the splay returned the value that you were searching for, then that means it was a match and it's going to return that value. Otherwise, it's going to return null. This is an insert, and after all of these checks, it also starts with a splay. Here's the removal. Starts with a splay, and then it does the split of the subtrees and then joins them later. Minimum, maximum. This is the in order traversal. It actually allows, immediately you can pass in a function so that you can perform operations on each node as it traverses. However, this is not animated or visualized in the demo, so but it is in there. Contains is going to return a true or false value whether the object exists within the tree. Here's the splay rotation to the right. Here's the splay rotation to the left. And those rotations are used for the actual splay, which is here. This is zigzag, then zigzag, and this is the opposite version of zigzag and zigzag. Continuing down, and then this is where it gets into the visualization. So I had to create a wrapper or a traversal that turns the splay tree into something that's compatible with D3. Basically, just kind of assigning everything into a JSON object. Um, Here's the main program that kind of gets everything together from D3 and draws the tree, and then all the event operations down here for all the buttons and everything. So, okay. Um, all the other code is available here as well. So this is a tree that I went ahead and put in, but we can actually come over here. Okay, so if you want to add something, then you just put in a key value and a string. So let's just call this key, it'll be key 10, and then the value is Denzel. And just add it. It starts at the root, and every node has two child nodes, two leaves. So they're always there, and they'll get filled in as it goes along. So like if we add in somebody else, or just say Washington. So key 15 added Washington. So now the left child of Washington is Denzel, and everything else is empty. So this is how a splay works. So like if you put in 12 and Robert, then 12 is going to go in the middle of 10 and 15, and is also going to be the root. So that means Denzel is going to be the left child, and Washington is going to be the right child. So you can continue this process with whatever values you want. And in this case, 234 is greater than everything, so it becomes the root, and everything else is part of the left subtree. So insert, remove, and find are all going to perform the splay operation. So let's remove 15. Removing 15 splits everything, takes the left subtree, and the 12 is going to move up to the root, and then the right subtree is connected in. So now if we did a find on 10, it's going to move 10 to the root, and everything else is going to reconnect. So you can also find the max, which in this case is 234, and you can find the min, which is 10. This is another tree I created to show what a zigzag would be. So if you search for 10, then this is going to be a zigzag, because 10 is going to move around the parent, which is a right child, and sorry, actually, if you do Downey, then Downey is a right child of the parent, Denzel, which is a left child of the grandparent, Robert. So, and Robert is a right child of Walken. So it's just this zigzag pattern. So let's go ahead and search for 12, and you're going to see everything move accordingly. So if we search for Robert now, this is a zigzag. Well, actually, if we search for, let's just go ahead and reorder this real quick. So if we search for Christopher, then this is a zigzag, because both the grandparent and the parent are on the right side. And the same thing would happen if they were both on the left side. And 20 moves to the top, and everything has been rotated. So it still maintains the order of the tree, you can still walk it and go 1, 5, 10, 12, 15, and then 20. And if you want more information, you can always click on this button and the screen is going to appear and show the same description that exists on the GitHub repository. Okay, so this is my splay tree visualizer, and I hope you enjoy it, and if there are any questions, please let me know. Thank you.